Welcome everybody to an event organized by the American Nuclear Society's Informed Performance-Based Principles and Policy Committee, RP3C we call it. My name is Prasad Kadambi and I am chair of RP3C. The purpose of RP3C is to help modernize ANS standards. Modernization has come to mean that risk-informed and performance-based methods are employed to overcome the difficulties that we all have encountered with purely deterministic and prescriptive approaches and methods. We've been calling these approaches and methods RIPB for short. The Nuclear Energy Innovation and Modernization Act specifically mentions RIPB. If you look around, you will find it hard to find any place other than ANS, outside of NRC, of course, that has as much information and guidance on RIPB. Overall, there's a lot of guidance available on RIPB, but most people have not had reason to become familiar with the information. This is primarily because the conventional approaches still dominate most things we do, including standards development. RP3C has been having these community of practice events regarding RIPB and associated methods, such as systems engineering, to enable practitioners to share their knowledge and experience. We have been scheduling these sessions on the last Friday of each month. Today is a special occasion because for the first time, we will have a community of practice session in which an active NRC staff member is going to make the presentation. I believe that this is consistent with what we hear about NRC being transformed. And I look at the presentation today as part of the communication of what the staff is doing actively and soliciting input from a broad community, such as people who tune into the community of practice sessions. So it gives me a special pleasure to welcome Stu Magruder of the NRC staff, who I've known a long time, even when I was at NRC. And I thank you, Stu, for coming forward and helping us with these community of practice sessions by sharing your experience and knowledge. Go ahead, Stu.
Well, thank you very much, Prasad. It's a pleasure to be here. I've listened in to many of these sessions and I've really enjoyed them. I think this is obviously it's a great, talented and experienced group of folks. So I'll do what I can to contribute to the discussion here. So the title of my presentation, and this is actually Prasad and I kind of collaborated on this topic. I want to talk a little bit about the NRC staff experience to date with advanced reactor vendors and how they're applying risk-informed performance-based principles and how the NRC staff is trying to employ them also. So let's go to the next slide, please, Pat. So first, some opening thoughts and a disclaimer. The context of my discussion today is going to be, Part 50 and Part 52 licensing, because that's where we are now. That's, the vendors that are interacting with the NRC now are all planning either a Part 50 or Part 52 application. But I do want to say that there is a lot of good discussion in the Part 53 rulemaking process now. And I think we've actually even gone to monthly meetings on Part 53 and got a lot of good input from folks. And at the very end of my presentation, I'll show you a link or how to get to more information on the NRC website about that. The other thing I want to mention is when I talk about advanced reactors, I'm talking only about non-light water reactors or Gen 4 reactors. I know that there are applications for new types of light water reactors, which are innovative, but I'm just going to focus on non-light water reactors. This is a general discussion. I'm going to try not to talk about vendors specifically. I know I've seen from the attendance list there are several people from vendors, so I'll try not to mention anything specific to them. I want to make this a general discussion. And finally, and most importantly, these are my thoughts. This is not an NRC official presentation. So with that out of the way, next slide, please. So let me start with what the NRC staff starts with, right? What are the kind of the basic findings that the NRC staff needs to make and the things that we need to look at? This is very familiar to most people here, I think, but I wanted to kind of just highlight the words here, and that is, of course, 5034A4 is just a paragraph I chose, but there are similar paragraphs in Part 52 and the various types of licenses you can get there. And this is the technical information required. And I just wanted to highlight that the staff needs to be able to determine the margin of safety for the design you're proposing, for the different aspects of the design, which implies that we need to know a minimum amount of information anyway about the design so that we can understand how far away the design is from safety limits or from failure. So there's, there are a lot of questions from the staff, not only about what you're proposing, but how you know where you are in the safety spectrum, how you know, how confident you are that you have margin, and what evidence do you have for that margin. So next slide, please, Matt. So another really important standard, and again, most people are familiar with this, is 5043E, right? These are the additional standards in Part 50 for designs that are different from light water reactor designs. And I just wanted to point out that, that this regulation exists, to make sure everybody knows it, and that, it tells the staff that we can only approve a design if the performance of each safety feature of the design has been demonstrated, right? The independent effects among the safety features of the design are acceptable, and sufficient data exists on the safety features of the design, right? So that's one set of standards for these new advanced reactor designs. So that this kind of gives you guidance on the things that the NRC staff will be looking for. Obviously the devil's in the details, how much information you need, how robust the data is, what kind of testing is available, and things like that. That's what leads to a lot of the discussions with the staff. But it's important to keep in mind that the NRC needs to have this information in order to make our findings, okay? So the other part of this, and the next slide, please, Pat, is if you don't want to do the analysis or testing, everything like that, then you could also use a prototype plant. And that you know, the prototype plant obviously could demonstrate that. But of course, as we've discussed, you know, over the years at many public meetings, the prototype plant, we generally, well, probably would impose additional requirements, right? And it says it could be on siting, safety features, or operational conditions to ensure that if something does happen at the prototype plant, that the public is still protected. So I just wanted to kind of set the ground rules there for what kind of things the NRC staff is required to look for. Next slide, please. So there are general issues for these advanced reactor designs, right? And these are very obvious, but just to point them out, I mean, obviously there's lots of different designs, lots of different technology, and importantly, there's lots of different sizes of the reactors that are being proposed. They range from, you know, a few tens of megawatts to hundreds of megawatts for these designs, and obviously they have different safety implications. Of course, there's also limited codes and standards and limited guidance documents. I mean, I should, you know, emphasize that the industry, DOE, the NRC have been working over the years to develop more of these, and more are on the way. You know, I think some of the important ones are some, you know, the ANS standards, obviously, on sodium fast reactors, high temperature gas reactors, the good work that was done on advanced reactor design criteria and things like these are all helpful. Not to mention the, you know, some of the ASME standards for high temperature materials and things like that. But there's still a lot of gaps in the guidance, which need to be filled somehow. Right. Next slide, please, Pat. So what this means, you know, basically is that a performance-based approach is required. We need to think about things at, kind of go back to first principles and think about how a safety case can be made, what documentation is needed, what information is needed, how it's presented, so that it's understandable, and things like that. And I'd say that the advanced reactor designers that I've been talking to in the NRC staff have embraced this performance-based approach. You know, obviously, Part 53 is attempting to do this as well. You know, the risk-informed, performance-based, technology inclusive approach that's needed for advanced reactors. Next slide, please. So the performance criteria, which are necessary for a performance-based approach, obviously, I mean, ultimately, the performance criteria, the important one is obviously the dose to the public, right? And the NRC has the quantitative health objectives, QHOs, you know, which are essentially, you know, making sure that both acute and latent fatalities are limited or proportional to, you know, general risks to the public. And that's what we have been basing our standards on for years, and that's what we plan to continue to do in the future for reactor designs. In addition, we go back to the fundamental safety functions, which are described in IAEA standards, and which we've kind of implicitly used at the NRC for many, many years. And those are obviously, the first one is to maintain radionuclide barriers to prevent any radionuclides from escaping to the public or getting where they shouldn't be. And then kind of subordinate to that are controlling reactivity or heat generation and controlling heat removal. So those are things that obviously we're looking at for Part 53, but we're also keeping in mind when we review advanced reactor designs that we're seeing now. Next slide, please. So I wanted to talk a little bit about fuel qualification because I think that's it's an important topic. Obviously, it's it's kind of basic to the fundamental safety functions we're just talking about, and also there's a lot of good work that's gone on for fuel qualification for advanced reactors here. Obviously, there's many different types of fuel and approaches to fuel forms for the advanced reactors. Everything from ceramics to liquid fuel for molten salt reactors. So it's a very broad range of fuel types and enrichment types as well. Obviously, a lot of the designs are talking about high assay, low enriched fuels, which have advantages, but obviously there's challenges in the fuel cycle now for that. But that also leads to challenges for the NRC staff in in trying to apply codes that are not currently benchmarked or okay for the higher enrichments or the different fuel types there. So some fuel is similar to previous design, obviously, but it's been used in different conditions. So some vendors are referencing previous operation of reactors or tests that were done, which is fine, obviously, but along with that, the staff needs to understand how your fuel will be used in your reactor, what the conditions will be, how it's different than how it's been used before, and there's a limited data on some of these fuels. Again, as I said, you have to ensure it's good for the design conditions of your reactor. Some of the fuel that there was testing done, but the tests were done under different conditions. So there have been topical reports submitted to the NRC, and we've approved actually a couple of them to allow for using data from old fuel tests. There was good discussions on that. And I'll show you that the NRC has published generic guidance on how to approach fuel qualification, which I think is a helpful document, and at least I hope it's helpful document for reactor vendors or fuel vendors. And again, that kind of goes back to the first principles too, looking at the fundamental safety functions and how the fuel affects the safety of the reactor, and how we can confirm that it will act as we can understand the performance of the fuel. Let me put it that way. So next slide, please, Pat. So another topic here, and I know there are people on the call who are much more expert than me on this topic, but I want to talk a little bit about event selection for these reactor designs. Certainly, we don't have the decades of experience that we have with light water reactors, so we know which events are more important than others. So we need to think about how to identify those. And one of the most important things, and one of the things that the staff thinks about often is, how do we know that we've considered everything, or at least everything that's important to safety? So the staff expects a systematic, methodical approach by the vendor to evaluate events, so they can demonstrate to the staff that they have considered everything. I know there have been some workshops. I actually was able to participate in one down in Oak Ridge a couple of years ago for molten salt reactors, where they looked at events to consider, and there was a good discussion there. So I think there's been some of that for other reactor types too. Certainly gas reactors, high temperature gas reactors and sodium fast reactors have a little bit more experience. But this is something that the staff is always going to ask. How do we know that you've considered everything? And what process did you use? Of course, I think the LMP is a great process. I think it's been well thought out. Obviously, there's a lot of work that's been done to develop that. It's based on a lot of experience with the various programs in the past. But it's not a requirement, obviously, and vendors can choose to use a different approach. But if they do that, then one of the things that you have to think about is, well, what is the maximum credible accident for your design, and how do we assure that? So that's something that we need to determine. We need to make sure that we understand that, and we also need to understand how you intend to use that. Is it for SSE classification? Is it for siting purposes? Are you going to try to use that to determine your emergency planning zone? How are you going to use this? The accident you choose, or the different events that you choose for your reactor. So this is a question that we will be asking and are currently asking the designers. So next slide, please, Pat. So again, this is a topic that many of you can speak about very well, and that is the risk-informed approach. How detailed does the PRA that you use need to be? And of course, that depends on the application of the PRA. You need to understand the uncertainties in the data that you use. There's been a lot of, many of you probably have heard at public meetings, a lot of folks who are not in favor of nuclear power are very critical of trying to do a PRA for a new reactor design where we don't have a lot of specific information. So there's a lot of emphasis from the staff on understanding where you got your data and whether or not you really understand the uncertainties in the data so that you can do an accurate risk assessment. Another question is, how do you mix PRA with other approaches? Do you want to use PRA only for certain applications, and do you want to try deterministic approaches and other approaches? How do you mix that? We're certainly open to that, but we want to make sure that you have a good story for that. And then, of course, can you just do a bounding deterministic approach? The answer is, of course, yes, but do you want to do that? Do you understand the implications of doing that? So there are a lot of, questions that the staff will ask you about that. So I think I just have one more slide, which will leave us a lot of time for questions, I hope, here. So I mentioned earlier that I wanted to show the NRC public website, because I realized that it's not always easy to find things there, even for NRC staff. But I did want to go over that. So Pat, if you can click that, hopefully that will take us to the NRC web page.
I'm not sure if you can see it. I am trying. However, I'm sharing an application, so I'm only sharing PowerPoint. I'm going to have to stop the share and then open the website. Perhaps maybe it'll just take me a second.
Okay, sure.
Okay, I believe that I should now be sharing my screen. Is that what y'all see?
Yes, thank you very much. So if you'll scroll down, Pat, on the left side there, you see in dark blue, it says Spotlight. And advanced reactors are one of the issues in the Spotlight. So if you click on that, that's the easiest way to get to our public website. And then, actually, this is relatively new format for our advanced reactor website. So it may be unfamiliar to some folks. But if you scroll down, Pat, you can see we have different topics there. There's a link to vision and strategy documents, which we've been developing over the last 5 or 6 years, I guess. And some of you may have actually contributed to some of those documents there. So there's a lot of good information there. The next icon is rulemaking and guidance. And that's where you would go if you wanted to learn more about Part 53. There's a lot of good documentation there. There's summaries of past meetings and presentations. There you can get a link to what's going on now with Part 53. Further down, policy development. It's where you can find the policy issues that we're dealing with. Significant things like emergency planning, security, functional containment, things like that are all within this policy development there. Next, you can see ongoing license activities, which is, you can see which vendors we're engaging with and what they've submitted, a little bit of information about their designs and where we are with them. The next one is stakeholder engagement. So you can see, many of you probably know that we have routine meetings where we talk about items that are of interest to, well, both the NRC staff and the industry related to advanced reactors. Next, we have international cooperation. So you can see links to some of the things we do that we're doing. Some of you may know that we have a memorandum of cooperation with the Canadian regulator. So we have several projects underway where we're trying to, well, doing several things. We're trying to share information that we've gleaned from various reviews, even do some potentially concurrent reviews for some designs, try to harmonize our approaches between the US and Canada. And then the last icon there, related documents, is kind of a treasure trove of contractor reports, NRC staff papers, and other links there. That's where you would find the paper I mentioned, the NRC staff paper on fuel qualification can be found there under related documents. So that's all I had prepared for today. I'm hoping that there are some questions or comments that I've prompted for during the discussion here.
Well, it's kind of amazing, Stu. I don't see any raised hands, but I'd like to ask about how the technical staff at NRC are dealing with this whole idea of modernization and going to sort of a different way of doing things.
So as you can imagine, Prasad, some people are more enthusiastic than others. I think we're very fortunate in the advanced reactor area to get a lot of talented people who are interested in taking a new approach. In simple terms, the advanced reactors are kind of the new topic, new exciting field at the NRC. And so there's a lot of interest. We don't have any trouble getting staff to respond to requests to participate in things associated with advanced reactors. So so we can be pretty selective in who we want to work on these things. So in general, I think we've got people with a lot of who are open to transforming and new approaches. Yeah.
Hey, I do see a question in the chat from Bob Youngblood. I don't know, Bob, did you want to go ahead?
Oh, yes, thank you. Has anybody tried the prototype licensing approach that you mentioned? You had one slide that was, somewhere in the back of 5034, I think.
Yeah, it's actually 5043, Bob.
Sorry.
That's okay. No, that's too many. Too many numbers. Yeah. Nobody has said that they're going to do a prototype specifically, but several vendors are taking similar approaches, I guess. For example, Kairos Power has announced that they're going to build a test reactor right in near the Oak Ridge site, which will be licensed as a test reactor, a smaller version of what they hope to be their commercial reactor. So that's one way of doing it, right? Is to build a small version under our test reactor licensing process to demonstrate things. I know that TerraPower has announced, actually got an award from DOE to build I think they call it the molten chloride reactor experiment, but that will be authorized by DOE, not the NRC. We think anyway. So that's another way to approach it, right? To get data for a commercial reactor at some point. There are other ways to do it besides building a prototype.
And it looks like we've got another comment. Go ahead.
Yeah, no, I'm just reading the comment from Sarah for a prototype approach. Or Sarah, do you want to read it and explain it?
Hello, can you hear me?
Yes.
Okay, I work for X-Energy, which I'm sure you're familiar with.
Yes.
And we are going through and putting together several accidents analysis, well, for different failure mechanisms. And we have access to a number of previous iterations of the high temperature gas reactor design. Usually there's been some modification in the fuel. We went from prismatic fuel to pebbles, having the control rods inserted directly into the core to only being inserted in boreholes in the reflector. However, we're still trying to nail down the final commercial reactor design that we're going to build in Washington. So I wanted to know how similar does it have to be to the historical designs for the results from those designs to count. Case in point, we have a great deal of data from the Germans. They built the AVR experimental reactor as well as the THTR 300, which was a pebble bed reactor. We have a lot of information from that. However, it wasn't something that was actually, involved with the NRC. So I wanted to know if results from that initiative would be considered applicable under the prototype proposal or the prototype approach that you have, or what do we have to do to use the results of those experiments?
So that's a common question that we get from vendors. And the answer, of course, is it depends. And I'm not trying to be flippant. I mean, the data that you get, well, let me say, so the difference in the fuel type obviously is important. And that we would expect that you would provide information on why you think that the experience with the different fuel type is applicable to your current fuel type, and what tests you've done to demonstrate that the properties are understandable for you, and how you're going to qualify that fuel. For other tests that are being done, if you can show that they bound the design that you have now somehow, then that would be acceptable as well. We have accepted international data before. That's not a big issue as long as we understand the conditions that it was that they were done under and things like that. Have an idea of the QA, and again, it depends on how you're going to use it. If you're going to use it to just show that you understand the design, that's one thing. If you're going to try to use it to support important safety analysis, then obviously that's a different level of information that we would need, or a different pedigree.
There's a question from Bret Kugelmas. Bret, you can go ahead and state your question.
Yeah, I was just looking through a lot of the documentation. It seems that a lot of these topical reports for advanced reactors often come with the qualification of non-LWR. I was wondering how the staff, might interpret that in their discussions. Was it just to make sure that to show that non-LWRs are being considered, or is it specifically to exclude LWRs from those topical reports and some of the decisions made there?
So the NRC talks about advanced reactors as non-light water reactors, mainly because because there's so much information that already exists for light water reactors, and we're focusing just on how we can accommodate these different designs. But some aspects of some of the things that we're doing obviously could apply to light water reactors as well. For example, the emergency preparedness rulemaking or the security rulemaking. You know, if licensees can show that they meet the entry conditions, you know, for those, then they could apply it. I mean, it's just that there's so much more unknown about advanced reactors. We're kind of focusing on that.
Just for quick clarification on that. So anything that says, here is how we're thinking, here's our strategies for non-LWR, you could apply them to LWR. It is not specifically excluding LWR.
In most cases, yes. I mean, obviously, if we're talking about sodium coolant, then you know that wouldn't apply to light water reactors. But general big policy issues, yes. Some things are technology independent, I would say.
See, there's a question from Mark Joseph. Mark, do you want to go ahead and ask your question orally? Let's see, maybe he has difficulty with the audio. Oh, there he is. Go ahead. Mark, are you able to state your question? Maybe I'll just go ahead and read from the chat function.
Yeah, go ahead, Prasad.
As far as defining the margin of safety, is there a definition reference? And are you applying this mostly to design features or to such things as reactor protection system settings?
So there are lots of definitions of margin of safety, right? Well, for the current regulations, right, for light water reactors, right, there are many prescriptive regulations which explicitly or implicitly define margin of safety, right? So so for advanced reactors, there's not, in many cases, there's not a clear definition, and it's up to the developer to define what margin of safety they have, and maybe more importantly, what margin of safety they need. And that depends on other things. I mean, there are trade-offs, obviously, in the design. And if you have a large margin of safety, you may have more operational flexibility. So it's really up to you. There's no, I think, for many cases, there's no set definition of margin of safety. Now, if you're going to follow the licensing modernization project or that path, then obviously there are quantitative margins that you can learn, you know, based on the frequency and the consequences of the event sequences that you have. So that's a good way to do that and to demonstrate that. It would apply also to tech specs. You know, if you want to do that to protection system settings as well, of course. But it's really up to the designer to determine how much margin you have and how much you want, and that gets back to the the testing and the data that you have. If there's a lot of uncertainty in your information, obviously that would reduce the margin of safety that you have. So I hope that answered your question.
Well, Stu, may I take the liberty to sort of amplify on your answer?
Yeah, please, please.
Because, there is an NRC document that formally defines margin of safety in a certain way, and that is the guidance on performance-based regulation, New Reg VR 0303. It takes a certain approach, and I don't want to get into the details of it, but as part of the LMP project, there has been more sort of detail that was explored in an LMP document, and that's available on the ANS website, on the RP3C web page, and I'll be glad to point people to it. But there is in New Reg VR 0303 and some supporting documentation, there is an approach to defining a margin of safety and using it in the licensing process.
Yeah, thank you, Prasad. It's a good document, actually, and we do refer to it now.
Okay, it looks like people have had their questions answered. Stu, I think it goes to your credit that among such a large number of people, you have not raised any more questions. We tried to...
Can I ask a question, Prasad?
Yeah, by all means, George.
Thank you, Stu, for a nice presentation. I've been following the debate on Part 53, and some people propose that the LMP should be an option in Part 53. Now, you said that the LMP is an option in Parts 50 and 52. If we make it an option in Part 53, how would Part 53 differ from 50 and 52?
So that's a good question. Thank you, George. So obviously, the LMP is meant to help define licensing basis events and classify or categorize your SSEs and approach defense in depth. And that that process is required regardless of which licensing approach you take. I think it's, but again, it's an option for Part 50 or 52 now. You don't have to do that. For Part 53, the difference would be it would fit more easily within the regulatory framework. In other words, I think it would be easier for the staff and the developers to understand how that fits with the high-level fundamental safety functions that we're proposing in Part 53. So I think it would be a more seamless, maybe an easier way to approach it. But I think it's a powerful tool regardless of the licensing path that you take.
Thank you.
You're welcome.
There is a question from Bret again. Bret, do you want to go ahead and state your question?
Yeah, I'll just jump in real quick and ask it. The types of methodologies that we're talking about, the risk-informed, performance-based, I know this is new for the NRC, but are there different divisions within the NRC that have expressed higher or lower levels of enthusiasm to incorporate this into their licensing strategy, such as like medical research or power. You know, these different regulatory divisions, are some of them more ready to go with it than others?
So let me correct you, and if I didn't, George would probably. This is not new to the NRC. We've been doing risk-informed performance-based for many, many years. In fact, Dr. Apostolakis led a team to look at applying risk-informed methodology across all the areas that the NRC regulates. So I would say that you're right that there has been a recent, maybe more public emphasis on.
Sorry, I know you guys have familiarity with the tools overall. I think I meant more for licensing an entire new reactor from scratch, which I think it would be more of a new thing for the NRC, right?
Yes, certainly non-light water reactors or advanced reactors are requiring us to take a different approach. That's correct. And I mean, the whole agency is, you know, attempting to transform, as you've heard from, you know, various different forums. So yes, we're trying to use, I think the term now is be risk smart, right? We're trying to use risk-informed performance-based approaches across different areas of the NRC, materials licensing, and
but I guess my question is,
non-power reactors.
My question is there one team that's more ready than another to do it? So for instance, is the team that licenses non-power reactors, are they like standing up and saying, we want to be the first to apply this from the get-go in a new reactor, or is it the power people that are doing it?
So non-power reactor is actually an interesting case, because generally the guidance for non-power reactors is not risk-informed. I mean, they use maximum hypothetical accident approach for non-power reactors because it's easier. It has been easier, and the consequences of accidents of these small reactors are so low that they can take that approach. So, I mean, that's not to say that you could not apply a risk-informed approach for a non-power reactor, but most, actually everyone to date has not done that. But let me, I guess, generally I would say that every aspect of the NRC is open to new approaches, right? To using, to being risk smart, and to trying to focus on things that are important to safety, and put less emphasis on things that are less important to safety.
Okay, there's one more question that has come in. Sarah, do you want to go ahead and state your question?
Oh, I was just going to respond to a statement that Stu made. I wanted to know what would be the difference between licensing a reactor to generate only process heat versus the same reactor generating power. Are there different rules?
Generally, no. If you're going to generate process heat for commercial applications, I'm assuming, this is not a test reactor, but a commercial reactor. Sarah, is that what you're talking about?
Yes, we have the option of taking the same reactor design, same control systems, same operators, and instead of appending a turbine generator, we would just have it as process heat.
Right. So that would still be considered a utilization facility, and it would be licensed as a commercial reactor, Section 103 of the Atomic Energy Act. So that would be the same as whether you were going to generate power for the grid or just process heat. It would be the same process for us.
What about when we submit an application for our XE Mobile? That's our suitcase reactor.
That we're still working on that. That's an interesting scenario, and it doesn't fit neatly in any of our processes now.
Okay, Stu, I think we have approached the hour mark. I want to thank you again. You know, this has been a very interesting and you know, well attended session. And you know, if people have any questions, you're welcome to send them to Pat Schroeder and myself, and we'll try to get back to you. I'm sure Stu will help us answer questions. Let's see, there's a question from Annie Kammerer about will the slides be available? Yes, all the slides and also a recording of the session will be available on the RP3C page of the ANS website. So again, thank you all for attending. Thank you, Stu, for you know, helping us you know, with making risk-informed, performance-based a little better known among all the people who are interested in it. As you know, we at ANS are also trying to do that as hard as we can. So we'll see you all at the next Community of Practice session, end of May then. And again, Stu, thank you very much. Pat, is that it?
Thank you.
That's it. Thank you very much.
Okay, thanks all.